Is my screen visible? Am I audible? Is my screen visible?
Yes, ma'am.
Good morning.
Good morning.
Yes, ma'am.
Thank you. So let us start.
Yes.
Okay. So today we will continue our discussion with Secret and we'll continue talking about shared memory programming model, parallel programming model, which includes deep thread and open-ended. So we've seen this last time that POSIX 1003.1c defines the thread interface of the threads, and Unix provides this library which helps you to create and manage threads, and it is well built so that you don't have to worry about how the implementation is done in the background. So we saw this function where we create a pthread by providing it an ID. If there are any attributes to be provided, the start function that thread will execute, and any arguments that you want to pass to this start routine. We also saw the pthread join, which will then wait. This function waits for the thread that you created to complete whatever task it has done,
I'm sorry
and
to
then
interrupt
join
you.
the main task. Yes.
Ma'am, your voice is not clear actually. Unable to understand sometimes in
Okay.
between.
Is
So
there
it's,
any
I mean, there is no internet issue. I think it's the headset issue or some issue because it's, I mean, it's not understandable sometimes.
yeah. Is there any background noise?
Now it is better, I think.
Okay. Uh, is it because of any background noise, or is this better?
No, this is better. There was no background noise even previously. Only thing is that the voice was not clear. Now it is clear.
Okay. Okay. Fine. Yeah. So
Just check the
okay.
volume levels as well, ma'am. Volume level is also low for us.
Uh, okay. I'm using the same headsets that I use on. Uh,
Okay.
yeah. So I've
Okay. Can you?
reduced the. Yeah, there was a background noise which I've now. Uh,
Okay.
There is no background
off.
noise, I think, ma'am. We are not
Yeah,
able
we
to
are
hear
good.
Okay.
any.
We are good now.
Yeah.
Yeah.
This is
Yeah.
better.
Please.
Better.
Yeah, it is
Okay.
better. Please start over again.
Yeah. Sure. Sure. Okay. So the first function that we saw last time in pthreads was pthread create. With this function, we can create a thread. Okay. For uh, which along with the function that it needs to execute and the argument this function needs. Right. The next is pthread join. Once you create a pthread, it will eventually join the main thread after completion of the task that is assigned. So pthread join will help you to then join this thread to the main thread. Okay. This is the example that we saw last time where we are creating a thread. So this thread is expected to execute a message, whatever the message is, along with because the message will be sent as the argument to this pthread message function. Let me just use a pointer. And then this function will be executed by this thread. And once the thread completes, it will join the main thread. We have seen this diagram also in the last class where thread create will create the new thread. The thread will print the message, and once the message is printed, it will then join the or be part of the main thread, and there will be no two threads after the join. Okay? There will be only one thread. There is another explicit function which is available to you, which is pthread exit. This is used. This exit is a system call, and all the threads are terminated by the OS when we have a pthread exit. Okay, so or if you there are two ways you can either use the exit function or you can close the main function. Once you close the main function, even then all the threads will get terminated. Okay, so in pthread exit you have to provide the status where the exit status of the thread will be sent, which will pass the status variable in the pthread join function, and it will wait for this one to complete. This is how the pthread exit looks. So in this function, okay. So here, what is happening here?
Here we don't have pthread exit. We have pthread join.
No, we have exit on
The
in
Oh,
print
okay.
message
exit is in
function.
the main function. Yes.
Okay.
Okay. So
So, ma'am, what status will it print? Do you have that code running somewhere?
yeah, we will. Code. Okay. Otherwise, I'll just copy that code. Done.
Can you put this in a notepad file? It's hardly visible in this editor. Notepad will give us more room.
Okay. So I'll just first execute this, and then I'll put it in a file.
Yeah, that's fine.
Either you can close the right hand panel. Welcome to Cadipod. Okay. Yeah. And
Copy here.
Printf statement, I think you need to be for
Hmm?
next to thread, the two. Like if you observe 16th line,
Yes. 16th line.
printf next to bracket, it needs to give correct commas, something.
I think inverted
No, no.
commas, we need to just
Uh,
rewrite that.
Okay.
Uh,
I
Put
think
it
I think
put it
because
in
I
It
the
Because
has
it's
copied them.
correct. It has
I
copied
copied them.
control
Yeah.
characters, not in the
Hmm.
right way. So
Yeah. That's why.
there are some in method as well.
Hmm?
There should be
I
ladder.
think
certain
if you
things in up
if you scroll up, yeah.
Okay.
scroll
This
up.
was
Yeah.
yes.
Hmm.
I think one
and
more is
in
there.
14th line, you need to give comma instead of a list.
14.
Comma. After
Uh,
double quotes, you need to
yeah.
put comma.
Yeah.
Yeah.
Yes.
Yeah.
I think it should be either its status, right? Or
The status
okay,
and
okay, star you've mentioned.
hmm. So the ID will be int and thread ID is p thread ID. So person B may not, it's not okay. I'll just for now keep only the status. This is okay. I think yeah. I think I'll correct this code and then upload it on Conda. Sorry, Elan, I meant. I'll fix it and then upload it.
Ma'am, can you do one thing if
Yeah.
it's possible?
So
When you upload this presentation, can you
uh,
also add the slide of output in this presentation?
yeah, I'll do that. I'll add the present output here after fixing the code and I'll upload the code as
Okay, thank you.
well. Yeah. So so the difference between pthread and pjoin, pthread will terminate a thread, whereas pthread exit terminates a thread, whereas pthread join will wait for a thread to terminate. It ensures that thread gets terminated. Okay. Pthread exit is called within a thread, while the pthread join is called from another thread. Okay. So the main thread calls pthread join, and that's where the other thread will join. But the pthread exit is called by the thread itself. Okay, is it clear?
Can you
That's
repeat
the
again
difference
one
between
more time? Ma'am,
yeah,
can you repeat it again?
yes. So yeah. Okay. So pthread exit is a function which is used to terminate the calling thread. Okay, what it will return is it will allow the thread to return a value to other threads after exiting. Okay,
Okay.
whereas pthread join is a function which waits for the thread termination. So it waits for the specified thread to terminate. Okay, you have to mention the thread ID that you want to terminate and the status. The main difference that which will help you to understand the difference between the two is pthread exit is called within a thread.
Okay.
Thread calls pthread exit, whereas pthread join is called by another thread for so that the thread it wants to join will join it once after the completion. Is it clear?
We and do we need to specify the thread numbers, or we can just say p thread join so
So
that
we
it
have
will join all?
Thread ID, I think,
so
needs to be
yeah,
given.
so that's why thread ID is given.
Okay.
So you have to mention the thread ID.
So now
Ma'am,
where
in this
in,
example, sorry, continue, Atta.
no, please go ahead. No worries.
Okay, ma'am, in this particular example, in the print message method, we have pthread exit as, let's say, third line of that particular method. So on on below line where we are creating thread, we are telling a new thread to be created, and it is expected to execute the print message method from the main
Yes.
method, as in the main thread. So once
Yeah.
we start execution of print message method in separate thread, pthread exit will come into context and it will exit the termination of the new thread created. as soon as it
Yes,
hits the
yes,
pthread exit lane, right? Now, in this example,
yeah.
assuming pthread exit was not there, even then
Hmm.
method is going to terminate anyways, right?
Yeah, it will terminate.
So what is the difference in having pthread exit and not having that line in this particular example? Is there any?
So, so in this particular example, the thread will now in this case terminate before the function finishes. Whereas if you do not use pthread exit here, it will come here. It will also it will be active for even this printf. Okay, and then
Hmm.
here it will join pthread join.
But anyways,
It
before
will
joining,
remain
it will exit, right? Even if you don't execute the exit specific explicitly.
in join. It will exit. Once it joins, it exits. It terminates.
So I think if we don't run
So
thread exit, pthread exit, then anyways my thread ID one will exit before joining, right?
yeah. So joining means it terminates. Na? It joins the main thread.
So pthread exit. So in which cases will I use pthread exit? Why will I need to exit from a certain thread
So
explicitly?
in case um let's say so in case if you want to exit, let's say before uh you don't want the thread to be active throughout the execution, like throughout the execution of a code. Okay, and you do not want to use the join, then you can use the pthread exit to terminate it before only. Okay, so or if you want to enable any thread to return some value to other threads. So, or let's say when a thread finishes its task and it just needs to exit and does not have to continue. Or even when, if, in case if a thread encounters some error, okay, and if there is an error, it needs to terminate. Even in that case, you can use thread exit there itself within the function that creates the thread. Okay, in case if you want to, let's say, check if there is any error scenario, and you created the thread, and then in the thread function only you check if the error exists. If the error exists, then close the thread. You do not need to continue.
Okay, ma'am. Got it.
Mhm.
Okay. Now
Ma'am,
the
on the
next,
earlier slide, I'm sorry, on the earlier slide,
yeah,
so what you're trying to come at is pthread exit needs to be invoked inside a method which is executed by the new thread, so that that thread execution will terminate at that juncture itself and will execution will return to main method in a way, right?
yes, yes,
The
yes.
method which has created that thread, in other words.
Hmm.
Right. So if we don't have pthread exit, then print message will get executed, completed. Then it will come
Hmm.
to pthread join point. Till that point, the new thread will be active, is what you said.
Yes, yes, yes. Because you
O-
cannot call pthread join in the in the function of the create thread. Pthread join will always be there in the main function.
Right.
Okay?
Right.
And
There could be a
yeah,
situation wherein we are
but
spawning
pthread exit.
another
Yeah.
thread from print message method also, right?
Uh,
Okay.
maybe yes. If you want, you can do that. You might need to. Yes, if you want, you can do it. It's a thread can then create another thread. That can be done. So, so
Okay.
what are you suggesting? What if you want to
No, no.
create a
As in the pthread join, let's say there is print message and print message one and print message two. Okay.
hmm,
Let's
hmm,
say from main method, we start a new thread for executing print message one method. Inside print message one, Let's say we create another thread and we
Hmm.
execute print message 2 inside that for that
Hmm.
thread.
Hmm.
Now inside thread 1, I have created thread 2. So only thread 1 knows that there is something called as thread 2. So it can wait
Hmm.
for thread 2 inside print message 1 method, right? So pthread join can be part of print message 1 is what I'm trying to comment. Would that be right understanding?
No, no, no. Pthread join has to be part of the main function. The main thread, because uh, these new threads that you create finally have to join the main thread, right? So
But
Okay.
pthread
ma'am,
join is
I think
called by a thread for for other threads to join it. So it has to be part of the main function. It cannot be part of the uh, you know uh, the other function. I mean, you should avoid doing that. Yeah.
no, but
Okay.
if we
Sorry.
have
Someone.
multiple, sorry, to cut you off, ma'am. So just one thing on, just a follow up
Yeah.
on this question, right? So, for example, what I think Yuvraj is trying to say is that if we have multiple threads, right? Right now we're talking about a single thread which is joining into main onto my thread
Yeah.
0, right? But if we have
Huh.
multiple threads, then how will they, because they will directly join to thread 0, or they will join with each other, or how is it? Where will they join? How many joins will we have?
So you can put joins in a for loop. So you can create a for loop and provide thread ID of each thread ID and square bracket I for in that for loop, and create call the join function. So multiple threads that we can join in using a for loop as well. Or you can call this pthread join multiple times, each time giving a thread ID.
Okay. So effectively what you are trying to say is uh, main is the method inside which we should create all the threads of execution. Let that let those threads continue their job via providing respective methods which they need to execute once they are started, and main thread needs to join for all those threads
Yeah.
in theory. So that like every method which we give to thread might take different execution time. So we need to wait until all those threads, as in the longest thread of execution, that finishes, comes back to main and joins it. Till that time, main method is going to wait until
Yes.
all of them
Yes.
finish their execution.
Yeah.
We cannot spawn a new thread inside another thread, as in thread 0 is the main
We
thread. Thread
can.
1, okay, we can.
We can.
Okay, I'll just try
Possible
and
to
put an
create.
example. Let's say we
Yeah.
have thread 0, which starts
Hmm.
two different threads. So
Hmm.
the thread 0 knows thread 1 and thread 2 are spawned by me. So it can wait on
Hmm.
thread 1 and thread 2 because it holds those thread IDs with it, right? So in that situation, fine, mean knows these are two threads spawned by me and I'll wait until those finish. So that's fine,
Hmm.
straightforward. Now assuming a situation, thread 0
Hmm.
starts a new thread, thread 1
Hmm.
starts thread 2.
Hmm.
So main doesn't
Okay.
have any view of thread 2. Only thread 1 knows I have thread 2. So thread 1 can wait for thread 2 to finish. Main doesn't even know that there is something called as thread 2, right? So pthread join
Mm-hmm.
has to be in execution code of thread 1 so that it will wait for thread 2 to finish, come back, then thread 1 will continue from that particular point onwards, will come back to main, and then inside main pthread join will hold on to thread 1 and then will finish off main method, right?
Okay.
So
Yeah, that's an interesting, yes, scenario. So in that case, the pthread join, if it is in the main function will need the ID of the thread. If it wants to join in the main function, then the ID will have to be passed from this calling function to the main function, right? Otherwise, it will have no idea about these threads. That's what you are suggesting.
yeah, that's what I'm
If
trying to
it gets
ask,
the
as
thread,
in
if it gets the thread ID, the main function, if we can pass the thread ID to its main function, then it can create, right? It can join them later.
Right. I'm just trying to kind of
Yeah.
resemble this with method calls, right? Method, you have method 0 calls
Mm-hmm.
method 1 calls
Mm-hmm.
method 2 kind of a situation. I'm just trying to correlate my understanding in context of function calls with thread context. That's why I'm asking this question.
Okay. Yeah, I understand. But what I was thinking is, see, if you use the join function inside any thread creation function, don't
Mm-hmm.
you think it will defeat the purpose of multi-threading? Because you are putting the join function in the function that is creating the thread. So it will be like sequential. Will that not be the case?
Oh, I see. I see. I see. Yeah, I get you. So yeah, yeah.
Yeah.
Thread one will create a thread, then thread two will execute. Thread two needs to finish and come back in thread one. So thread one will wait until thread two finishes in a way. So they will not work in parallel is what you are trying to comment.
Yeah. Yeah. Yeah.
Okay, so it's better idea not to create a thread inside thread. Whether it is allowed
Ye-
or not, I'm not sure, but that is
Yeah.
not a good idea
I
technically.
I guess it's allowed. I haven't tried it myself, but it is allowed because it's technically possible. Can create, but it will defeat the purpose of multi-threading.
Yeah, they won't work in parallel is what you are trying to comment. Though it
Ha
is
ha. Yeah.
technically
Yeah.
supported, those will not
Yes.
be executed in parallel.
Parallel.
Mean is the right place wherein we should create all the threads of execution, let them do their work in parallel and come back in main. That is legitimate
Yes.
situation. But
Yes.
thread creating thread, as in intertwined threads, may not be a good idea from parallel execution.
Yeah. From that perspective, but it is doable. But you'll have to handle it and expect the performance accordingly,
Yeah, yeah,
whatever
yeah,
you are trying to do.
yeah. Agreed, agreed. I was just trying to kind of correlate to method call so that we understand it better.
Yeah, yeah, that was an interesting yes. That was an interesting example, and we got to explore that idea as well. And yes, we can go back and try how good will
Yeah,
be.
we can try and see if that's yeah.
It will be
Thank you.
interesting to see what will be the difference.
Yeah.
Oh, so yes, moving on. Now we have learned that we can create threads, join and exit them. The next step is how do we synchronize these threads? And there are three basic synchronization primitives which are available to you for doing this. Mutex locks, which are locks which allows you to lock a specific part of the code and allow only a single thread or the thread which has the access to this lock to continue and do the task. Condition variables, this allows you to create a condition. Once the condition is satisfied, then the thread will get the hold of the lock and it will do the task it needs to on a common region or common variable. And the third one is semaphores. Semaphores helps you to assign a counter to this particular whatever condition it is, and based on this counter, it decides whether you get access to a common region or a common variable which you want to work on. Okay, we'll see now each one of them. How do you use them? What are what is the application of this for each synchronization primitive and how it helps you to design your code using pthreads and ensure that your data is not corrupted or is not prone to race conditions. We'll start with the mutex lock. So a mutex lock is created like any normal variable. So you call pthread mutex p mutex. So this gets uh, initializes the creates the sorry, it creates the mutex lock, then initialization is done using init. In initialization, you provide empty, which is a pointer to the mutex lock to initialize, and then attribute, which is usually a map, mattr, but an attribute you can provide to this init function. Then the next step is how do you lock? First, declare the mutex, initialize it. The next step is lock. So here, how do you lock it? When locking this locking function is used, mutex lock, it does not return until the current thread owns the lock. Okay. So if the mutex is already locked by the calling thread block, it will so basically what we are trying to do here is we are trying to use the mutex to ensure that we have exclusive access to any critical section of the code. Critical section of the code means the code that should be executed by only one thread at a time. Otherwise, if you do not have a lock, then the code, the data, the variables that are part of this critical section will be executed by multiple threads at the same time and we end up in corrupting this data. So hence what we do is we have this lock function. So this lock function should be, a thread should take control of this lock function and then execute the whatever is the critical section of the part. So in case of multiple threads try to gain this lock at the same time, the return order of this lock will be based on the priorities assigned to this thread. If priorities are assigned, higher priorities will get the lock first, and if there are no priorities assigned, then any one thread amongst multiple threads will get the access to the lock. The next step is unlocking. Unlocking is very important because if you do not unlock, then it will lead to a deadlock because you know threads will just wait for the lock complete to get complete. Okay, so calling the unlock function to release the lock is very important. And uh, once the lock is unlock is done, then any threads which are waiting for this lock will get the lock and do the or perform the instructions which are part of this mutex. So this is how you unlock it. So mutex unlock will here you have to provide the MP, which is the mutex to unlock, the ID of the mutex to unlock. So yeah, so take a look at this and tell me what is happening here. This is a classic producer consumer program where producer is trying to add elements to the buffer and consumer is trying to consume this added elements in this buffer. So in this example, the buffer becomes a critical variable because only at one time only either the producer should have an access to this buffer or the consumer. If both try to access this buffer at the same time, then there will be issues because it might so happen that producer is trying to produce and consumer is trying to consume at the same time. If they get the access to the variable at the same time, the value of this buffer will get corrupted. Is it clear? The problem is clear. So now, how are you using mutexes here? Anyone wants to? As you can see here, in the main function, we have a buffer, which is the critical section of critical variable that we need to take care of. We have pthread p and we use a mutex which is created. So here we have declared this pthread mutex because we want it to be accessible to both producer and consumer. So then we create a producer thread. I think let's go to the BS code. I think. So, so this buffer size maximum can be 5 at a time. Only the producer or consumer will either produce or consume maximum 5 elements. Okay, and so let's first go through the main function. We have this buffer. We have two pre-threads, producer and consumer. We create the producer thread, we create the consumer thread, and then we have pre-thread join for both the threads once they complete. So first, let's visit the producer function. So in this producer function, we create, uh, we check if the count is equal to max size. If it is full, then we did not do anything. If it is not full, then we'll come here. Then we will get the log to this mutex of buffer log, and then we will add next character to this buffer. So we are trying to do add A, B, C, D, just to say that this is what we are producing. Okay. So then we get the character, add it to this buffer, and we say that we have produced this character. We increase the count, and once the count is done, we unlock the mutex. And then for just to simulate some production time so that we see some difference in terms of uh, the creation and deletion of the characters, we are simulating a bit of production time. In consumer, it will check if the count is greater than 0 because it can consume only if there are characters available in the buffer, right? So it will wait till the count becomes more than 1. Now once this there are enough resources available to be consumed, then it will try to get the log. So once it gets the log, it will do count minus minus, remove the character from the buffer, and then unlock. And as you can see, the consumer we are saying sleeps for these many seconds, that is 0.8 seconds, and consumer producer sleeps for 0.5. We'll see the difference in terms of execution of these because of this difference in sleeping time. Okay, is the problem clear? Anyone? I can go ahead and run this, or if anyone wants to want me to show the code again or discuss any specific function if it's not clear.
We are good, ma'am.
Okay, great. So I will go ahead and execute. Um, okay, so producer produced A, consumer consumed A, C, till even F it was fine. So here, yeah, here I think there is right. Okay, here the lag between the two sleeping time you could see because once the J were produced, J were consumed, producer since it's sleeping only for 0.5 seconds could produce K and L, but consumer consumed only L. K it did not consume. Clear? Any doubts here? The output?
Ma'am, sorry, that was not clear.
Yeah,
Can you copy the output in a notepad file and we take a closer look at
sure,
that?
sure.
Okay. So A, B, C, D, all of them are getting produced and consumed. Till E is also
Yeah,
fine. Now on F, I think from there the problem
yes.
starts. So F is produced, G is produced, but
Hmm,
consumption is done only for G. So kind
hmm,
of consumer didn't pick up F at all.
hmm,
Then we
hmm,
produced H, consumed H.
hmm,
Again, we move on. ING are produced, only J is consumed. So there are
hmm.
certain things which are getting dropped off, as in consumer is not consuming them in a way because of
They'll be part of the
difference.
array. They'll remain in the array because of
Okay,
yes.
because of difference in addition and consumption
Yes,
time,
sleep
as in
time
zero
that
point
may
0.5
vary.
and zero point 0.8. Because of that variation, okay, so that
Yeah.
character doesn't get dropped from the array, but it never gets consumed in a way.
Hmm.
Okay, okay. That's not a desirable situation though, ma'am, right? We want all the characters, as in it should be something like I producer creates a stream of data,
Hmm.
consumer reads that stream of data in the same sequence in which it kind of gets added, right? As in ABCD, if that is the sequence of character producer is going to consume, then consumer should read them in the same sequence. If it kind of drops certain characters in between, then it won't
But
be desirable, right?
it is not dropping. It is part of the buffer. Eventually, when the producer, when the buffer becomes full, so producer may not be able to produce and will have to wait for consumer to complete. Right there, eventually it might get be able to read those characters from the buffer. So they remain in the buffer. Okay. Now this sleep time is to basically create some real life scenarios. In case, let's say, the time that a producer needs to produce and the consumer needs to consume may not always be same,
That's true.
depending on what scenario it is.
Hmm.
And
Hmm.
we are trying to simulate such a scenario
Okay.
that where the two may be different.
Okay. Okay. I'll take a close look at the method and then
Sure. And
we'll
yeah,
try
sure.
and
I'll
yeah.
upload this code as well.
Right. Right. Ma'am, one more question. When this program is expected to terminate, as in you kill the program execution,
Yes. So we have not
how do
utilized.
we kind of stop this program in legitimate way is the question in a way.
Mhm. Yes.
Let's
So
say
here,
let's say we have a condition like we just need to add A till Z in the buffer, and after that producer should not consume producer should not produce anything. So buffer
mhm,
remains in that A to Z state, as in consumer will read the remaining characters because of its slowness, and then consumer also will finish off, and both of them kind
yeah.
of terminate in a legitimate way. How that could be achieved?
So that we can add here where in the in the or we can add it in the producer or the consumer functions that uh, if the produced item is uh, has reached now Z, check the what is the produced item, and if it has reached that, you exit. Pthread exit we can use here, isn't it? We can check what is produced,
Oh,
and if
yes.
it is red,
Oh,
it will
yes.
exit.
Hmm.
Once producer exit, the we can then put similar condition here that what consumer consumed is Z, then it can also exist. Pthread exit in this.
Hmm. Yeah, yeah, yeah. Agreed. Would you add that version of code also? Producer consumer
Okay,
without end and with end kind of a thing so that we can compare those two codes and understand it better?
sure, sure. I'll do that. Yeah.
Yeah, thanks.
Okay. Yes. So, okay. So the next synchronization technique is conditional variables. So in the previous example, we've seen using the log. Now this log we can, change, and we can use it to wait for a condition to be true. So the condition could be whether the buffer is full or empty. Okay? And this conditional, uh, there is a reason why the using conditional variables helps over mutex is that the stream log that we use in the mutex might require CPU time to run. Okay, it might waste a few CPU cycles. Okay, but condition variables, what it does is it allows a thread to block until a specific condition becomes true, and then will this is like a so the block condition, since we have already put the condition here, the process, the block process can run as soon as the condition is complete, and hence the extra CPU cycles that are needed get reduced in this case. Okay, so well, yeah. So how a
Sorry,
condition?
sorry,
Yeah.
sorry. In the previous slide, there is a mention of spin lock. Yeah. Where did we talk about spin lock in previous example?
So so basically the log, right? The mutex is a log. Huh?
Okay, but it is a lock, right? Spin lock, I thought it is something different than what we saw.
Okay. Um. Hmm. Okay. So yes. So yeah. The um. Yeah. So in stream logs, basically, we do not. It will not involve any context switching, whereas mutex logs involves context switching. So yeah. So uh. Yeah. There is difference. I agree. I agree. So here we have actually looked at mutex logs and we have not used stream logs. So hmm. Yeah. I'll change this side as well.
Yeah, so what you're trying to comment is there is something called as mutex lock and there is something else called as spin lock. Is that what you mean or my
Yeah, yeah,
understanding
yeah,
is wrong?
yeah. There is a difference between mutex logs and stream logs. So,
Okay.
and yeah, so mutex logs, are uh, used to block the thread, but stream logs use them, something like they do busy waiting. So where a thread tries to acquire stream log, which is already held, it will wait until the lock is released. It will keep spinning and wait until the lock is released. That's the difference. So basically, mutex locks are used for longer lock holds. Like when thread needs to perform some input output operation and needs to wait. Whereas spin locks are used for where there are like shorter locks which uh, where it takes very small time, less time to, but
Okay,
they are
if you
similar,
can
but
put up,
that's different. Yeah, I
right, if
will
you can
put
put
a
up an example of spin lock as well, and we cover that in the next class, that will help.
sure, sure, sure.
Yeah, can you just explain a bit about context switching? You mentioned about context switching while explaining this. Can you explain what is context switching to
Yes.
some degree at least, so that we can understand it better?
Okay. So see, yeah. So in terms of mutex locks, what happens is when a thread tries to acquire a mutex lock, which is already held by some other thread, uh, the OS will context switch and uh, it will try to schedule another thread, right? Context switching is done between threads. Okay. So then, while doing this, the block thread is removed from the scheduler's run queue and then it is
Mhm.
put on a wait queue when it is trying to do this context switching. Okay. But when it comes to spin locks, what happens is when a thread tries to acquire a spin lock which is already held by some other thread, it will wait, without giving the control back to operating system. So
Okay,
the
so it will
spinning
remain in
thread,
CPU's
yeah,
execution queue is what you're trying to comment.
yes, yes, the
It will
spinning
not
thread
be.
remains in the
Mhm,
scheduler's run queue,
mhm,
and it will
mhm.
continue to consume CPU cycles.
Okay,
So it will
okay, I see.
be active. It will remain active. So, why we do yeah, so yes, so why we do context switching is we are trying to save the current state of the thread, right, and restore the state for the newly scheduled threads, right?
Yeah.
Yeah.
Okay, okay.
So yeah, so that's the main difference basically. The spin locks and mutex locks have different trade-offs, between how they use the CPU, how the context switching overhead happens, and the delay or latency that both of them take. So with, based on what is your use case, you then choose between the two.
Right, I'll just try and summarize, ma'am. Sorry.
Yeah,
E-
sure. Go ahead.
Mutex lock is an exclusive lock. So if some thread tries to acquire that lock, and if that lock is already held by some else thread, then the thread will be blocked until that lock is released. So operating system removes that thread from execution queue and puts that in blocked queue so that CPU cycles are not wasted for that thread. Once that particular mutex variable, as in the critical section, is executed by earlier thread, the lock will be removed, and then this thread will be given a chance to see if it can acquire the lock again. If it get acquires locks, then it comes into execution queue, and then CPU cycles are spent on that particular thread. So
Hmm.
here we ensure that CPU cycles are not wasted as soon as we understand the fact that thread requires a lock which is not
Hmm.
available. That's
Yes.
exclusive kind of a thing. Spin lock is a different analogy. With spin lock, both the thread will remain in the execution queue. There will
Hmm.
not be a blocked queue notion in this particular context if we are using a spin lock. So after certain interval, one thread has acquired the spin lock, so it is getting executed. Other thread is waiting on a spin lock. Though it is waiting on spin lock, it will not be put into blocked queue. It will remain in the
Yes.
execution queue. Some cycles will be vested to see whether the spin lock is available or not. If it is not available, it will still remain in the execution queue. Again, thread
Yeah.
1 will execute, do its job. Again, thread 2 will come into context. We'll see that spin lock is still not available, and it will. So eventually,
It will
we'll
be doing
vest.
busy with.
Right, right. There would be a small interval wherein it will keep on polling whether spin lock is available or not. And
Yeah.
that's the
Yes.
wastage of cycles which we are talking about here.
Yes.
Okay, perfect. Thank you.
So yeah. So yeah. Continuing with the discussion on conditional variables, they are created like normal variables in protocol texts, where we say pthread condition t condition variable, and these must be initialized before being used, and it can be initialized only once. So, so in the initialization function, you have to provide a pointer to the conditional variable to be initialized and the attributes, if there are any attributes, which can be usually null, but if there are any specific attributes you want to provide, you can provide. Then there are two, you know, conditions that you can have. One is condition wait. So a wait call is used to block a thread on a conditional variable. So this puts the thread on a wait queue until it gets signal that the condition is true. Even after the signal, the condition may still not be true, but it allows you to be. It puts you on the wait queue. The block thread does not compete for any CPU. The wait call should occur under the protection of a mutex because this mutex is used because then it will automatically release the by the wait call and the mutex is automatically reclaimed on the return from the wait call. So we'll see an example and it will be better. Um, so a signal call is used now. That is, so the first one is wait. Now the waiting thread will have to be told that okay, the condition is now clear. The condition whatever it is waiting on is now true or false or whatever. Then the we, we have to call the signal function. Okay? So signal is basically it is like a wake up call to the signal thread, which is waiting for some condition to happen. So if there are multiple threads which are waiting, then any of them, randomly will get woken up. The thread which is woken up does not actually wake until the lock indicated by the wait call becomes available, and the condition thread that it was waiting for may not be true when the thread actually gets to run this again. If there are no waiters on a condition, signaling will have no effect. It will be of no use. So this is an example. Let's go through this example in the VS Code. Yeah. So before moving, I'll also mention that there is another option of broadcast. So here, in the example that we saw, we'll have an example where we are trying to wake a single thread. But if you want to wake up all the threads that are there and which are active, you can call something like a broadcast. So to do a broadcast, it will wake up all the threads. But waking up all the threads would can sometimes create a deadlock also. So you have to be very careful when you are using a broadcast, depending on what your application is, or signal is a better way to go in terms of waking up the waiting thread. So let us go through this code. Let's start with the main function. We are looking at the same problem, producer consumer using conditional variable. So here we create a mutex and we create a two conditional variables, not full and not empty. Now we create the two threads, producer and consumer, and once they are done, we expect them to join. Then we create the log as well as the conditional variables that we have created for these threads. Now in the producer function, we take the thread mutex log and while the count is equal to max size, we call the condition wait function, and here we provide what is the condition, that is not true. Then it will, so while the max size is not reached, it will wait till the buffer is full. Once the buffer is, once that you know that the buffer is not full, it will come here, create the characters, and it will say produce the characters. You see. Now once the, you know, once this is done, you signal the consumer that okay, the buffer contains some variables and it is not empty by using a conditional signal. Here, this not empty will signal the consumer, and the consumer will try to start to consume. Then it will unlock the lock. In the consumer function, but will, the consumer will have its lock. It will check the count, and then it will say that wait till the buffer is not empty. So once we know that there are characters available in the buffer, then it can start doing the consumption. So it will decrement the count. Once the character is consumed, it will inform the producer that based on whether the, the buffer is not full, it will signal the producer, and then it will unlock its lock to the buffer, and it will sleep. The rest of the function use care and get care remain the same. Only thing, this pre-thread condition not full and not empty are are common to both the function, hence they are public to global variables. That is
Can I ask a question here, ma'am?
sure, sure.
Okay, I'm trying to
Good.
compare this example and the prior example. There is a
Yeah.
subtle difference between placement of a while block. If you scroll down, if we can have, yeah,
Hmm.
can we
Yes.
have both producer functions from earlier program and this program pasted into
Sure.
Notepad,
I'll look on it.
one by one, as
Okay.
in we can.
Okay. Yeah.
Okay, if you can maximize the screen. I have a question in context of placement of while loop. If you see
Mm-hmm.
in the traditional example, as soon as we start the for loop, we check the
Mm-hmm.
condition, while condition,
Mm-hmm.
busy wait
Yeah.
if buffer full. Is there a way to bring in line numbers here?
Mm-hmm.
Maybe in the view also. If line numbers are there, we can refer to line numbers properly.
Check
Or if
and
you
I'll
have
just,
Notepad++, that will be better.
yes, I'll check. I need to do that.
You'll need to install that. Hmm.
Yes.
Okay, right. In the first traditional example, in the for loop,
Hmm.
we have a
Hmm.
while loop, as in
Hmm.
while condition equal to max says. So till the time
Hmm.
buffer is full, we should not progress further, is what that while loop will do,
Hmm.
right? It will hold the
Hmm.
execution there until we have space
Hmm.
in the buffer, and then we are
Hmm.
taking a lock after it. So once
Hmm.
we know that buffer is not full, there is a space to add a new character, then we take up the lock. So pthread mutex lock come after the while call, and we take up the lock, put the character, release the lock.
Yeah.
That way we ensure that we do not write beyond the buffer size. Now coming down to
Hmm.
the newer version of the code where we are making use of pthread condition await, we are taking up the
Hmm.
lock as soon as we enter the for loop. If you can highlight that line. Inside the for loop, first step is to
Hmm.
take the lock and then run the while loop. So is
Okay.
there
Yeah.
is that kind of a bug, or is that something which is intentional over here? Because if you see, we take up the lock, assume that buffer
Hmm.
is full, assume that
Hmm.
buffer is full. So while condition is max size,
Hmm.
it will
Yeah.
wait on not null condition, not full condition, and it is actually full. That's the reason the it has entered the while loop, right?
Yeah.
I'm not getting that clearly. As in, while
Hmm.
loop should be before taking up the lock is what I personally think. I'm not sure, as in if I'm missing something.
Hmm. Yeah. I get your point.
Right. This
So.
would be a deadlock situation, right? Wherein we know count is max size. Because it is
Hmm.
max size, I'm waiting on it. So pthread condition waits is not full, and it is actually
Hmm.
full. So that
Yeah.
condition will never get fulfilled. And it will just hog, as in it producer won't do anything, consumer wouldn't get to do anything because lock is already acquired by
Lock is
producer
already, yes. Lock is acquired. Actually, I also feel the lock should be after the
after the while
after
loop,
the while
right?
loop is complete. Yes. Yes.
Right. So
Agree.
until I have space, I should
Yeah.
not acquire the
Hmm.
lock. And same should
Yes. Yes.
happen in the consumer context
In
also.
the
As in, if
consumer
you see
context.
consumer code also,
Hmm.
exact same problem is there in the consumer code also.
Yeah.
There, let's try both the versions. I'm not.
Yes. Let's try. Let's execute both.
Yeah,
Let's
just
execute this
right,
and then we
and
will
see
see.
whether it
Yes.
is actually doing a deadlock situation
Yes.
or not. Let's try and do that.
Yes. Let's try. Yeah.
Can you reduce the interval of producer so that it starts putting more characters,
Yes.
and then we might
Already.
get run into problem quicker.
Mm-hmm. Mm-hmm. Yeah. So.
Make it one, yeah, instead of five. Yeah, and let's try and see if that kind of fills the buffer quicker.
Hmm.
We're still not losing characters, ma'am. So looks like
Yeah.
there is some problem. As in, if you see,
Hmm.
what is the wait time for on consumer thread? Is that
It's
8.8
eight. It's
seconds?
yeah. It's
Yeah.
0.8 seconds.
Now, if you see, okay,
Hmm.
there 0.1 second is the producer wait time. Consumer
Hmm.
is
Hmm.
0.8.
Hmm.
So producer is expected to produce more number of characters than what consumer is going to consume. So it should kind of
Hmm.
fill the buffer quicker. I'm not getting it.
Yeah.
I'm sorry.
Yeah. Even I understand your confusion. It should be able to fill it faster.
Right.
So
And then because of the way code is structured, we are taking up a lock as soon as the buffer is full. So that should
Mm-hmm.
put us in a deadlock situation. That's
Mm-hmm.
what my understanding is. Here
Yeah,
it is not
there
doing
should
that.
be.
No, not really sure why it is not
But
behaving that way.
mhm, yes, we'll have to play with the waiting times and see why, or because if every 1 second, 0.1 second producing, then the consuming is consuming 0.5 seconds. Uh, it should be able to, the buffer should be fuller sooner.
Yeah,
So,
that's what I thought. And we should get into that situation as in, and also instead of printing just a character, we
let's
can
just,
print the buffer at
yes.
every step so that we can look at the content of buffer also
We
alongside.
can, yes, yes. That will, yeah, that will help.
Right.
What I did was I
Oh yeah.
made,
Yeah. Yep. See here now we are into that situation which I was trying to anticipate.
yes, yes.
So produced number of lines are more, consumed lines are
Mhm.
less,
Mhm.
but still I think it is adding character still, is it?
So, no, as in it is produced, but it is waiting for character to be consumed. As soon as it is consumed, then only it's able to add.
But still it is not deadlock situation then.
No,
I
it is
was
not dead.
anticipating. I was anticipating a deadlock situation because the speed with which characters are getting produced are going to full the buffer. And as soon as buffer is full, we are holding up a lock. So there is no way consumer can read something. That was what I was
Mm-hmm.
anticipating. Something we'll need to see. I think I'm missing something.
Yeah. Um, so, okay, as soon as the box is full, consumer will not get the lock because of the, yeah,
Because producer has held
because
it up,
the
right?
lock we are taking, yeah, because the lock
Hmm.
is with the producer and we are not hold it down.
So there is no way character could be consumed.
Mhm.
Buffer will remain full, and producer will
Mhm.
keep on holding the lock. Consumer will
Mhm.
remain in infinite wait state.
Mhm. Mhm. Because Mutex has already acquired the lock. So that's not happening in this case.
Yeah, because placement of lock is the most critical part, right? Because
Mhm.
we want that to be exclusive, and at the same time, we don't want a deadlock situation as well. As in, there should be a way to kind of not get into that state, and everybody should take the lock, do the job, release the lock. Somebody else should take it, do the job, release the lock, kind of a thing. That
Yeah,
placement is very crucial.
it is important. Why in this particular case it is not affecting, we'll have to see placement of
R-
lock.
Right,
Mhm.
right. Okay, okay.
Mhm. Okay. So,
Ma'am, were you trying to show a broadcast example as well? And you said broadcast might put things in deadlock situation. Do you have an example of
no,
why it would
broadcast
not happen in?
no, broadcast do not have. I will include that. That means.
Okay, because see, until we can visualize things properly, it will be very
Mhm.
difficult for us to absorb that.
Yeah, and broadcast I
Yeah,
did not have an example. I will include that in the codes that I play.
okay. Now, pthread condition wait is going to just wake up the threads waiting on the same lock is the idea.
Hmm.
There
Yeah.
could be, let's say there are two consumers, for example, which are waiting
Hmm.
for that lock. Producer is producing at higher rate, consumers are consuming at a slower rate. We have two consumer thread
Hmm.
and one producer thread. Let's kind of take that example. So what you were trying to explain is p-thread condition wait will just wait one of the consumer one or two, we don't know, but either of them. So only one will compete for the lock. And
Hmm.
since one is competing for the lock, there are good chances that it can get the lock. But if we wake up both of them together, both of them will try and acquire the lock. That's the race situation, as in competing situation, right?
Yeah.
And
That
that will
can be
be
a
a
good example for broadcast
right.
with
Broadcast is going to put us in
more
that
than one.
example. Hmm.
Yeah, yeah. I'll
Okay,
try
so
to create this producer consumer problem using a broadcast. No,
right.
and
So if we can have an example of one producer to consumers and we deal it with p thread condition with how it behaves. If we deal
yeah,
it wake up all kind of a
uh,
situation how it
yeah,
behaves
with a
and then
with a signal and with a broadcast.
right. How that the difference is highlighted is what we would like to see, as in that will help us to understand things better, as in which one should be used. As you
Sure.
said, broadcast should be used in a preset situation wherein we are very clear that we are not going to
Mhm.
get into deadlock situation. How to anticipate that situation until we can visualize that it will be difficult for us to choose between either of them, right?
Yeah, I will.
So an example will help. Yeah.
Sure, sure. I'll do it. I will do it. Mhm. Okay. Yes. Moving on. Let's. So the next type of synchronization technique that we use with keythreads is semaphores. So with semaphores, what we can do is we can have some specific conditions which can be some variable which can be incremented or decremented, and that will increment or decrement the semaphore's value. So we can take a semaphore, initialize it to any value, and the thread will get blocked if the semaphore value is less than or equal to 0 if someone is trying to decrement it. And as soon as the value becomes greater than 0, one of the block threads will wake up and it will continue. But which thread it will wake up, there is no guarantee in this using semaphore. But as soon as the semaphore value becomes greater than 0, the thread that is being blocked will wake up. How do you create semaphores? Are using it like all the variables that we've seen so far. It is the sem underscore t, the semaphore variable. You have to initialize the semaphore to a particular value. So provide the semaphore value to initialize. If there are any, if you want to share semaphore across different processes, you provide this value and the initial value for this semaphore. There are two functions for incrementing and decrementing the semaphore. The first one is int sem wait, which it will check and it will try to decrement the semaphore. So if the semaphore value is greater than 0, the same wait false will return immediately. Otherwise, it will block the calling thread until the value becomes greater than 0. How do you increment the semaphore? Is using post. So this increments the value of the semaphore by 1. If any threads are blocked in the semaphore, they will be unblocked once it is implemented. So whenever you are using post, you should be careful because whenever you use post, the semaphore value will get incremented. So let us see an example. See my example using semaphores. To get care use care remain the same. In the main function, you create the log, the semaphore you want to use. One is for empty, the other one is for full, and max size is used to provide the empty slots how many are needed. Then you create the two threads, three thread create consumer and producer, and then the join once we finish the task. The pthread mutex destroyed will destroy the mutex lock and then destroy the semaphore using sem destroy. So both the semaphores empty and full. In the producer function, we create the character and then we wait to see if there is a empty slot. After waiting, it creates a lock and then adds an item in the buffer. Then and then it releases the lock. So once there is an element which is added, it will inform the semaphore using a post. So post will increment the number of it is like the count that we used in the earlier example. Semaphore count will get incremented. Now in consumer, it will wait to get the check whether the semaphore count is greater than zero. Once it is greater than zero, it will then acquire the lock, take the item out from the buffer, and then release the lock. Once it is done, it will then post that there is an empty slot. So we've simulated the consumption. Let us run this code. Let us increase the consumer time. This is interesting. Consumer is consuming in an order. You observe here. Why do you think that is happening? Then what we saw in the earlier examples.
Yeah, I'm also wondering about it. In the earlier example, whatever character was getting produced, it was consuming
That
it.
Mhm.
Here there is a difference, as in
yeah. Doing it in order what we expect, the way we expect it.
exactly, and that was my earlier question as well. Consumer should read in the same sequence.
Same sequence. Change here.
Ma'am, in printf, can you just put a buffer content also so that we'll understand things better? Line number 34, reduce character C. Put it on the same line so that it will be more intuitive. Just say produced percent %C comma buffer equal to
So, but buffer we will have to provide
percentage.
yeah.
Then we'll need buffer at the end. Yeah. So it will keep on, and if there is a way to do the same in consumer also, so that we'll see
Mm.
what is buffer in producer and what is buffer in consumer. Use care. I think use care will need to modify.
Mm.
Yeah, consumed, and then here we can do the same. Yeah, let's see how this helps. This is better, as in we are able to see consume
Mm. Mm.
P.
Mm. Yeah.
If program is tweaked to kind of take off the character from buffer once it is
Mm.
consumed, probably that
Mm.
can give. Currently, it is not, as in every time buffer size is same, remaining same that way.
Yeah.
So
Yeah.
we are not
Yeah.
able to kind of visualize things. It is not helping in a
Mm.
way. I'm sorry. Hmm.
No, no, yeah, it's not. The order of characters in which it's consuming is not clear from the book before.
Hmm. It's not clear.
Yeah. Okay. We'll have to see how we can visualize this buffer, how bring this buffer in such a way that we can use better.
Right.
Um,
Right.
uh,
And then if we can tweak the program, as in
hmm.
producer will write at the end, consumer will read from the beginning, kind of a thing.
Hmm. Hmm.
That
Order
way it
this
will.
order.
Mm,
Yeah, just
that
to
way it
visualize.
will. Yeah, but at least the sequence of characters would remain the same
Hmm.
that way.
Hmm. Hmm.
So if you can tweak the program that way and kind of put up an example which we cover in the next class, that will help us to kind of visualize this better.
Sure.
Ma'am, it's very difficult to grasp these concepts if you see. As in, not all of us will be having, as in, I personally haven't worked on multiple threads. It was always singular for me. So these examples are very important for us to absorb.
Yeah, yeah, yeah. Yes.
And then what is the difference between them? That difference is the most vital point. If you see, what is the situation which mutex cannot help me with, so that I
Hmm.
need to use condition.
Use
And then how
condition can
semaphore is helping us to
doing
achieve, as
better
in,
than condition.
correct, correct, correct. So until
Hmm.
the
Hmm.
differentiation is there, we won't be able to
Hmm.
understand things better.
Yeah, yeah. I agree. I agree. Even I'm kind of in the previous parallel computing courses, I've never dealt with P threads. This is the first time actually I'm covering P threads because found I felt that they are essential, as a stepping stone in parallel computing. I feel you should uh, work with threads at the level of granularity that P threads provides. So
Hmm.
that's why I thought of introducing it in here. This is the first time I'm doing it. So yeah, and I thanks to you all, I now know how what is the clarity that we need when we play with these people. So
Right,
I'll try
right.
to. Yeah.
Right, and there is
Because
adverse
when you
background.
see
Hmm.
when you see OpenMP, when you see FPI, which I've covered it previously also, you do not have to think about all these things in, at this level of review. Because
Okay,
that's where you were kind of doing like batch processing, kind of thing you will get. You will work with OpenMP. Whereas Pthreads is you're looking at the redundancy of threads, which is actually very fun as well as interesting and yeah, challenging as well. So
correct,
yeah.
correct, correct. Yeah, in even with MPI, like I will just take up this opportunity to explain another
Sure.
problem. As in with MPI also, see,
Mm-hmm.
parallel programming is a different paradigm altogether. And typically,
Mm-hmm.
if you see, all of us think in a procedural way.
Yeah, yeah.
Thinking in
Agree.
parallel notions, as in you try to put up examples, you try to give us the context, but that was not very clear even with MPI that way. As in,
Mm-hmm.
typically whatever matrix multiplications we do in our ACADs and all, those are pretty smaller matrix multiplication problems. So we never
Mm-hmm.
kind of understand the power or the problem having a bigger matrix, and then how we are
Mm-hmm.
kind of breaking that matrix into different pieces, how individual process computes their compute their part of the matrix, then leader thread comes into context which collates the results, and then we get the answer kind of a thing. It's very difficult
Mm-hmm.
to kind of visualize that,
Yeah.
and until we
Definitely.
kind
Yeah.
of visualize it, forget about programming it, as in which MPI call does what. As in we covered
Mm-hmm.
that portion which helps us to understand the calls which are there in MPI. But how to
Mm-hmm.
look at the problem, how to break the problem, how individual process is going to work on their respective problem in order to bring out the result, and then how those results are going to be collated by result the leader thread and given as an output. Let's say we have two
Yeah.
variants as in a sequential program with which is given, let's say, 1000 by 1000 matrix, and if it takes, let's say, 10 seconds, if we have that version and the answer also, right, we don't want to do incorrect things in parallel, right? Result has to remain the same. So if we can have an example of 1000 by 1000 matrix, and let's say we
Mm-hmm.
sum it up in a procedural way, and it takes, let's say, 10 seconds. If we break that 1000 by 1000 into four pieces, let's say, and we have four different processes which are working on, now it would be 1000 by 1000 was the original size. Individual will work on 1000 by 250, right? If we break them
Yeah.
in four pieces. So they parallelly will do their job. Now those 10 seconds of sequential execution is going to
Mm-hmm.
get broken into four pieces. Okay, assuming
Mm-hmm.
they are going to do the job in a parallel
Yeah.
two sense, then within 2.5
Mm-hmm.
seconds, we are expected to see a result. Maybe 2.5, not let's say 3 seconds.
Mm-hmm. Well, yeah. It is.
Let's say 3 seconds because communication overhead is going to be there. Let's say 5 seconds. That's
Yeah.
that's also fine.
Yeah.
The point which I'm trying to make is until we see this kind of a difference, it will be very hard to even visualize how parallel execution is helping us to reduce the execution time. And
Okay.
that didn't come through. Maybe you might have had a
And
plan
this,
to cover
and
that up in lab or so, but the problem which I'm
yeah.
trying to put on is it is very hard to see. We are breaking the problem and it is getting executed in a smaller time. That would be theory part of things. But how does that happen in practical? Let's say 1000 by 1000 takes 10 seconds. Now it is taking, let's say, 3 or 4 seconds, and we are getting the same answer. Just
Mm-hmm.
extrapolating it further, let's do it 5000 by 5000 matrix. Sequential is taking, let's say, 50 seconds. And parallel,
Mm-hmm.
we are doing it in 15 seconds, for example. Until that differentiation comes in our context, we will not be able to enjoy it, will not be able to
Okay.
understand it. So if we can do something of that sort, so that everybody of us starts feeling that it is a fun and not kind of a maths, right? For now, to be very honest, though I'm trying to ask as many questions as possible, once a session's over, I go through recordings also. But I'm
Okay.
unable to kind of enjoy it, to be very frank with you.
Okay. Okay.
I'm I'm
Okay. I
I'm
get.
thinking like I'm not really sure how this is being done, kind of a thing. As in it is becoming maths for me. It is not fun. It is
Yes.
it is hard to grasp kind of a thing. So if we can bring up this visualizations in reality, theoretically we can
Mhm.
compute. Let's say there are four processes. We are assuming this much delay and this much is the expected improvement as against the
Mhm.
sequential. So theoretically that part is something which we can try and understand to a certain degree. But until that comes in practical context, we will not be able to appreciate that part. So I'm not sure what
Okay.
plans you have, but until
Mhm.
we see something of
Yeah,
this sort.
I'm planning to revisit MPI for sure because we have not, uh, you know, used it at like multi-node kind of a scenario where
Correct,
we have
correct.
yet to explore that part, and there are some parts of Model 2 that I want to cover there as well. So, uh,
Right.
but what I thought was, anyways, I started with secrets, so I'll complete the shared memory, you know, models,
Hmm,
programming
hmm,
models
hmm.
first, and then move back to MPI. So there, I'll try to, try to include whatever suggestions you've given now, and try to see if I can, help you to visualize these
Correct,
things.
correct, correct. See, and then another aspect of it, I'll just try and cover that as well. We are approaching midsem exams,
Yeah.
and you suggested you have already uploaded last year's questions which were asked. I tried to go through
Mhm.
them as well, and to be honest, I had a hard time to understand those problems and then translate them in context of MPI calls, which would be required. Yes, on ChatGPT, on all we can put that problem, get that answer. That's one story of it, but that's not going to help us. We need to have that thought process inside us so that we read the problem, we break the problem, we try and figure out which MPA calls will help us in this situation, and then eventually we should be able to code as well. So until that happens naturally to us, it is going to be very hard for us to get through the exam
Yes,
content that way.
I
So
will. I will get. I mean, sorry, the course was conducted by someone else. I think in the last semester. I need to check what the question papers that are uploaded. I haven't
okay,
actually. Yeah, I need to check what is the difference that you are mentioning. So I'll go through them and
right, right.
then. Yeah.
There were three questions. Two questions were based out of MPA, so I was able to at least understand that particular part. Third was
Mhm.
probably related to p thread, so I didn't go through it. For the two
Okay.
problems, if you can go through and see, only questions are given. Each question has 10 marks, as in there are three questions, 30 marks. Now out of
Mhm.
10 marks there is 5 plus 5 kind of a scheme, so I'm assuming that flow would have 5 marks. 5 marks would be for problem. If you can go
Mhm.
through those examples and bring up model answers, as in,
Okay.
so that we'll understand what is expected out of us in context of an answer, so that we'll get how many marks or something of that sort. Basically, if one
Sure.
is good at understanding flow, he writes the flow, let's say, and he does the
Mhm.
job well, he'll get 5 marks kind of a thing. The one who
Okay.
writes flow as well as code correctly, he'll get 10 marks, something of that sort. And if we have a
Mhm.
model answer in front of us, then it will help us to visualize that better. And more importantly, see, exam is part and parcel of learning, which everybody of us understand. But that's one of the most
Mhm.
important step to progress further. So getting through exams is also as equally important for us to learn. And I would like
Yeah.
to see learning and exam go hand in hand, as in we should not prepare for exam. We should learn and we should get automatically prepared for exam. That would be the right way for us. And
Yes, yes, that is the plan, and I also ensure that I stick to what I've covered in the, during our contact sessions, and
Mhm,
what problems are, what discussions we have. Will
mhm.
The questions will be asked based on these contexts only.
Right,
Mhm.
right. Maybe lab
Mhm.
session, if lab session happens in between and we
Mhm.
see these things in action kind of a thing. See, you can take up last year exams paper and look up the examples and we can solve them, or you can put up your own
No,
example. That doesn't matter.
I'll be
Hmm,
putting up practice questions. I'll be putting up this week. Yeah, this week I'm planning to put up a few practice questions, which are
hmm,
meant, which are will be like uh, lab sessions which are similar to what I do on campus as well. Okay?
Perfect.
So
Okay.
these are like yeah. So these I've first used to practice before I yeah, on campus we have like lab uh,
Right. Right.
sessions which are evaluated also. But
Right,
yeah,
right, right,
it's
right.
not
See, there is
sure.
a huge
But
difference doing it in the way we are doing. Yes, on
yes,
campus
yes.
it is going to be different. But if we
Hmm.
can go closer to what you do on campus, and
Sure.
let's say there are five examples. You start off with a simpler example. You build up the story. We write the code that follows up with a more complex, as in we add flavor to complexity flavor to it, and we progress in that particular direction. You may not run them through in class the way we are doing it right now, but if we have something of that model in the offline period, we can go through that kind of a document, understand the problem, try and do it on our own, something of that sort. So that is going to help
Yes.
us to understand things in a finer way, and until we do it
Sure.
that way,
Sure.
it is going to be very hard for us to kind of even visualize what we are going to do in exams.
Yeah. I
Uh,
get your point.
Yeah, and another point is, as in all of us are not from computer science background that way. And
Yeah.
second part is experience level is also different. And then
Mm-hmm.
whatever our day job is, that may
Mm-hmm.
not actually require day-to-day coding or something of that sort. As in the
Mm-hmm.
background is varied, so you might have some context that people might be knowing this much, and then you might start from there. I'm trying to ask as much questions as possible. I'll encourage others also to do that, so that we kind of make best use of this time.
Yeah. Yeah,
Parallel
and it
programming
helps. These
itself.
questions and
Hmm,
this discussion really help you all, help me in
correct,
understanding what is lacking, and also helps us to, then reflect even post the class on what we should try out or what we can experiment, and you know these discussions are really helping everyone. So I also would encourage everyone to participate in this discussion. Whatever maybe your query could be the serious, and you might feel that you do not know a few things because you do not have the background of C, or you are not well versed with programming. So do not hesitate, ask questions, be part of the discussion. It helps all of us, not just you all, it
correct,
helps me too.
correct, correct. And particularly this subject is bit difficult, ma'am. If we compare it with other three subjects, at least we feel we can do something there. But this subject is fairly difficult for us. It's
What are
something new.
the what are the other three subjects you all are?
We have network
Mm-hmm.
fundamentals, then big data, and third
Mm-hmm.
is cloud computing.
Okay. Okay.
There is bit of theory
Yeah. Yeah.
over there. So
Mm-hmm.
theory, and it is kind of combination of and even the question papers are combination of theory and practical kind of a thing. But with parallel programming, it is going to be more towards program, right? That's the intent of the course
Um.
itself. So
Yeah, that's the intent of the course. But yeah, I'll ensure that there is some theory as well, because, as you said, that everyone is not very well versed in programming. So I understand. So
right,
I will see if I can include some theory questions as well,
correct,
because
correct. That will also
so
help.
that
As in
everyone gets yeah some benefit, because the the question paper has to be designed in such a way that there are easy to moderate to high difficulty levels.
perfect,
That I'll
perfect,
ensure
perfect.
while
Yes.
setting up the question.
Yeah,
It
that
will
that
not
will
be
really
any
help.
difficult
Hmm.
one.
Right, because last year's question paper, at least, it was fairly difficult, and probably all of us are going to not even score 5 or 10 marks, to be honest. If we just go with
Okay. Do not
that
worry about it.
analogy,
I
it
do not
was very difficult. That kind of scared all
no,
of us, to be honest.
no, I do not believe in setting up question papers which are not solvable by anyone. I think everyone should have a sense of fulfillment after answering the exam, of knowing at least something, some part of it.
Precisely,
Not
precisely.
think, yeah,
Yes,
that
yes.
that
Correct,
so do
correct.
not worry
30 out
about
of
it. I'll
30 is not
ensure that.
something which we are expecting. See, as long as we understand things to certain degree, maybe 50% is also
Yeah,
good
yeah,
score for us out of 30.
yes, yes.
But
So there
important
will
point
be
is to,
there
I'm
will
sorry.
be proper division of what kind of questions will be asked, and It will have easy to moderate to high
Difficult
difficulty level.
questions, right?
I'll
Right.
follow, yeah, I'll follow the guidelines that are already available, like that I usually follow.
Perfect.
I never
Perfect.
ask for only difficult questions. Do not worry.
No, I'm not trying to claim that that professor has done a difficult job for students. The point which I was trying to bring is
No,
that was given
but
to us. Hmm.
as you mentioned, the the batch that we have is around 150 or something, right? So those many students, I do not expect everyone to be very well versed with C. And in your day-to-day jobs, you may not have even time to spare in learning
Precisely.
C from, yeah,
Precisely.
scratch now. I totally understand the scenario.
Hmm, hmm,
Okay, and
hmm.
that will be considered in terms while setting up the question. Okay,
That will really help us. Yes, yes. And importantly, if we can see fun part of things, that is going to
sure,
encourage us
sure.
more. As in, we agreed that will need to put more time because we are kind of lagging to a certain degree, and
Hmm.
then there is syllabus to cover which you have your timelines as well. So if it
Yeah,
requires more sessions, as in if you see big data professor was lagging behind a bit, he took up an
sure.
additional session so that he can cover up the syllabus that way. And we are more than
Okay,
happy to have lab sessions if it is over and above your actual plan. If it is over and above, we would like to see the fun part. We would like to see complexity from simple to complex, how parallel programming is going to help us, something of that sort. If it requires additional time, we all will be interested in getting that through.
sure,
Whatever we
sure.
can do
And
best to ease up the
yeah,
pressure, tension, exam fear, that will help us a lot because exam is not too far. We have maybe 2 3 weeks time. Whatever we can
yeah, yeah.
do best out of that time, we should try and do. And this is one of the best subject, but it has become maths for us. We have started caring
Understood.
about it, and that's not something
Okay,
which
okay.
you would like to see us, right?
No,
We
no,
all
no, no.
should
I don't
should
want.
see the fun part of things.
Yes, yes. I totally agree. I do not want to scare you all off. So I want you all to learn and have fun, and understand, and appreciate the
Correct.
parallelism that we are
Correct.
learning through this course.
Correct. And that would happen only if we see things in action. As I kind of put up an example of 1,000 by 1,000 matrix, sequentially it takes 10 seconds, parallelly it takes 3 seconds. If we extrapolate that, let's say 10,000 by 10,000, time is kind of proportionate that way. So why parallel is
Sure.
important? If we can understand the basics of that, then it is going to be a fun. And that will
Okay. Okay.
ease up our nerves to a good degree. So if you can, as in,
Thank
we clearly understand that you also have your own weekly responsibilities, and this is kind of over and above your week's work. But if you can think in this direction, can try and piggyback on whatever you might be using for on-campus students, or if
yes.
there are some other associate professors who are helping you out, you can put up these things in front of them, let them help you so that you can prepare the material which is required for the class, and then we can make best
Sure.
use of our shared time, as in. And
Yeah.
again, see, we don't want you
Hmm.
to do everything. We are ready to do things more from our side also, but we should have some material which is going to help us to learn things in broken down way, not as a single piece. As in, chat GPT is will give me an answer, right? Whatever question I put, it
Hmm.
will give me an answer, but
Hmm.
it is not going
Hmm.
to break it for me. It is not going to give me the direction in which I need to think in order to get to that. It would be
I
right,
agree.
not cooking and getting ready-made food, and that's not going to enjoy the cooking part of things, right? We
I
would like
understand.
to cook and eat, not only it, kind of a thing. So if we can kind of, sorry, I've taken a good amount of time today
No.
and it was kind of not planned, but whatever we can do in this regards, that's going to help us to a huge degree. And then you'll
Sure. Sure.
appreciate the fact that people are enjoying things rather than being scared. So I just wanted to put that on front.
Yeah. 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 Thank you. Thank you for putting up all the points. And yes, and I prefer, continuous feedback kind of, during the, like, during the course of the, course, because then this feedback helps me to incorporate and make things better, or also tells me where I need to, improve and what needs to get fixed regarding those things. This is much better than you all giving some feedback towards the end of the course, and which may
Correct, correct,
which kind
correct.
of
That will lose
no
time
use
on
to you
both the
all.
parties.
And yeah,
Hmm.
yes, yes, yes. Because even if I improve on whatever you feedback you give towards the end, that is of no use to you. So this is much better. And
Right.
yeah, I'll keep these points in mind, and I'll try to plan the sessions accordingly. And hopefully from next week on we will have better and know, um, more sessions on the feedback that I've received from you today. Hmm?
Perfect. Yeah,
Okay,
that
so
will help us a lot. That will help us a lot.
sure, sure. I'll keep these points in mind
Right,
and
right, right. And if theory and practicals are closer to each other, as an MPI followed by practicals, or MPL theory session and then practical session, then again theory, kind of a thing. If we are fresher in that particular direction, then it will help us to grasp faster. So
I
if we
agree, I
can
agree. I
align them,
also
that
yes,
will help.
yeah. So I also yes want to just clarify that actually I'm not very happy with the way the syllabus is designed for this course because uh, the it is not aligned to any textbook. It is not the flow is very haphazard kind of, and I wish it could have been different. But I was not sure that me changing the syllabus once the course started will create some more confusion. What I
Okay.
do in yeah, but what I do on campus for similar courses that the syllabus is aligned to a textbook, and then I put these practical sessions in between so that it is
Hmm, hmm.
aligned, what I cover.
Exactly,
But this
exactly.
syllabus
Yep.
somehow, yeah, because of I don't know because some reason I got the syllabus also just a few days before the course started. Sadly, I
Okay.
didn't. I felt it is not the right time to then rework on the syllabus and might create some, more confusion for you all. That's why I stick to the syllabus, but I wish it could be different. But
Right. See,
uh, I'll
as
try
long as we,
so
right, as long
yeah, but
as we communicate with each other in a proper way, whatever suits well, you can arrive
yes,
at that. And I think all of us
yeah,
are
yeah,
open to that. See,
yes, and
important
that's
part
the
is,
plan. And
right.
I will, yeah, as I mentioned, whatever I covered in the class in the slides is what will be part of the or midterms. Do
Mhm,
not
mhm.
worry if there is something in the syllabus and is not part of the slides, or something is in the slides may not be part of syllabus. Stick to the slides and what is covered in the, during the contact session, and that should be
Okay.
enough.
Okay,
Okay.
perfect. That
Ma'am,
that
just
So
helps.
one,
That helps. Yeah.
ma'am, just
Mm.
one question on this, because why we are asking all of these questions is that if you, I mean, someone has already posted the last year's mid-sem paper, right? So
I okay.
if you look at the questions, right, directly it's asking to create the programs using MPI or maybe through socket or maybe through threads, and those are all
Mm-hmm.
scenario based, right? So
Mm-hmm.
considering the content in PPT, which is a mix of theoretical and the samples for the code, right? I
Mm-hmm.
think for not for all of us, it's that easy to create programs as per mentioned in the question paper.
I
I think that
understand. I
is
understand. So that will not happen. As I mentioned earlier, the question paper will be not exactly what is uh, uploaded, which is last is done by default by the team, uh, which is supposed to take care of it. But the question papers here, specifically for my course, will include all types of tense questions. There will be some theory, there will be some direct questions, there will be some medium difficulty questions, some difficult and some with slightly higher difficulty. So there will be a mix of these type of questions. It will not be what you have seen in the question paper which is already uploaded. Do not worry about it.
okay, ma'am. Thank
Yes,
you.
yes,
Yeah.
yes. That will help a lot. And lab sessions, as you said, if you can intertwine that, then even that is going to help us
Sure.
to understand MPI in a much better way. Sorry, I am kind of putting up a general question to cover almost all the students which are here. If anyone
Mhm.
else also would like to contribute, feel free to contribute. Let's try
Yeah,
and
yeah.
help
Please
each
go
other
ahead.
as much as possible so that we all will understand things to a good degree, and then we'll do better. The intent of this course
I
should
agree.
be to understand things in a better way, and then we should be able to use that going further. Just
I
clearing
agree.
exam
I agree.
should not be the only objective. As in,
Hmm.
after mid-sem, there are going to be 8 sessions, so we have time to catch up. Even by the end of EC3, if we are in a good shape, it will be really good.
Yeah.
So, ma'am, if you can do these things as gracefully as possible, that will help us a lot.
Sure. Sure. Yeah.
Yeah, thank you very much for hearing
Thank
us out, and sorry for taking up good amount of time.
Yeah, that's fine. This PDF feedback will really help me. And yeah, yes, as I said, I'm open to continuous feedback, and that will help both you all and me. So please do not hesitate. And yeah, you can talk during sessions if you want. If you're not comfortable, talking during these sessions and in front of everyone, then you can please send me a mail. My email ID I think is available to you all. It's gargi@goa.bits-pilani.ac.in. You can write to me as well. Okay? Even that
Right, right,
will be
right.
helpful. Hmm?
Yeah, will do. I tried to reach you on chat, but looks
Hmm.
like you were offline for most of the time.
Yeah,
Maybe.
sorry. Mails would be helpful. I'm sorry that yeah, teams I kind of end up checking only on the weekends especially. So
Okay, okay.
okay,
Sorry,
I
I
try to
wasn't sure
check in
about that.
between, but sometimes, yeah, because
Okay,
yeah, we do not use Teams for otherwise usually it's Google Meet. So sorry, I end up checking the chats just on the day of the session. You can,
right,
yeah, write to me. That will be better.
right. And based on whatever discussion we had, you can once you get some time, you can think through how you want this to be aligned. And as I said,
Yeah,
if you require more time, as in, see, you are helping us, and we will help you as well. So in order to cover all the section content which you have, if it demands more classes, we are open to do that. And in order to
yeah,
make us learn things better, if lab sessions cannot be accommodated in stipulated time, feel free to kind of block time so that we can have those lab sessions over and above whatever schedule time you had, so that you also
sure,
don't
sure.
kind of get trapped in a way. As in, the time game is always going to be there, and we'll need to adhere to that, no matter whether we want it or not.
I
And
understand.
other thing
I
is, on Saturday we just have one class. There are 3 classes on
okay.
Sunday. So if you
Oh,
want to arrange anything, Saturday second half is the best time. And as in, we
oh,
all
that's
have
great. Yeah.
signed up for the weekend, so we must spend time. So on Saturday, second half or continuation of this particular session itself, if everybody agrees to that, that could be the time slot which we can plan for going further.
Oh, that's
If you
that is great to know. Yeah, because I was checking with the team regarding this, and I was told that means, at least during week it is not possible. So I didn't know on Saturday I could schedule something in the week. That's great to me. So I
yeah,
will
yeah, just
yeah.
think through,
I'll
as in
I'll
all
keep
these
it in
inputs.
yeah. I'll keep that in
Hmm.
mind. I'll keep that in mind, and yes, if needed, we can meet on Saturdays in the evening
Correct, correct,
or
correct. And
continue
then
this session.
if
But
they are
yeah,
intertwined,
having
as in,
continuous,
hmm.
sure,
See, having those classes very close to exam are not going to help us. If those kind of scattered across, that will give us more
sure,
time and then right perspective to counter them.
sure. Let me think about all these points and then
Yes,
get back to you all and maybe announce rule on or sorry, e-learn.
right,
What is the
right,
plan for this?
right. Perfect, perfect. And weekdays are going to be difficult, as in all of us work at different times.
I
So
understand.
weekday
I
it is
understand.
going to be tight. But over weekend, I think
Yes,
people
yes.
should be ready. And then if people are not dialing, then it's going to be their problem. So let's not worry about that
Yeah,
part.
yeah,
As in, at least on the
yeah.
weekends, if people are expected to join, if they don't join, then we cannot help that. But at least let's try and help people who are willing to take extra pain.
Sure, sure. Sure.
Yes, thank you, ma'am. Thank you very much.
Yeah, yeah. Thank you. Thanks for all the uh, for all
Yeah,
the
and
feedback,
then
and if
as
there is
many
anything, then write to me as well.
right,
Yeah,
right, as many questions you can throw at us. That's going to be fine.
Yes,
Let's say this is a question, this is answer, go through it and try and learn it. That kind of exercise we can do offline on our working days. Whatever needs to be done together, we can plan for weekend.
sure, sure.
Thank you, ma'am.
Oh, yeah, thank you. Okay then.
Yeah,
So
mostly Uras covered all the questions from the students actually. The last point,
mhm.
whatever he raised, the questions and the relative answer, it will be very helpful actually. That we can get from
Yes,
ChatGPT, but we can't. It will not that much understandable format. So if you can say no, that it will help. Uh, Thank you.
yes, sure, sure. I understand.
Yeah.
Okay then. So I think yeah, we can stop here today. Um, with, yeah, what kind of summarizing the synchronization part that we discussed today, which was about using mutexes, semaphores, and conditional variables. The uh, mutexes are used where we can allow only one thread to access a resource at a time. Whereas in semaphores, what we do is that we use a signaling mechanism which allows uh, you know access to multiple instances and multiple friends can access simultaneously using a counter. Conditional variable is where we wait for some condition to be true, and we do use vertices in all fields, but in semaphores we have a counter. In conditional variables we wait for a condition. In terms of ownership, a thread must unlock the mutex if it is locked. uh, you know, there is no ownership as such on unlocking the thread. It is based on the semaphore, the variable. And in conditional variables, it is about the condition that threads are waiting for. Mutex is either locked or unlocked. Semaphore is could be binary, 1 or 0, or it could be a counting semaphore. Conditional variable, there is no value as such, it waits for some condition. The purpose of using mutex is it helps you to block a thread if another thread holds this lock. Semaphore is when, based on the semaphore value, if it is greater than 0, it if it is less than 0, it blocks. If it is greater than 0, it allows. And in condition, the thread block is until there is a conditional variable, it's true or false, and it's then signal. For signaling in mutexes, you have to unlock, and unlocking will automatically wake up the block thread. In semaphore, when you do post, it will do the increment, and then this post will signal another thread. In conditional variables, you have to use specifically either a signal or a broadcast. They will wake up the threads. Use cases of each of them is protexes are used when you're trying to protect some shared variable or data structure. Semaphores are used when you're trying you to use some count, such as for the example that we saw for producer and consumer, where you use buffer. Conditionally, if you want to wait for some conditions to be true, which again the example that we see, use a buffer. The in terms of accesses, mutexes can be used when we want to provide a lock to only one thread. In semaphore, multiple threads can pass if counting of the semaphore is greater than one. And in conditional variables, the threads wait until some condition becomes true. Hmm. With this, we can stop today, and next week we will, discuss a few examples that we are wanting to discuss from what we, you know, tried today, and also then start with the open end. So yes, so thank you. We can yeah stop for today.
Yeah, thank you, ma'am.
Thank you, man.
Thank you. Thank you, ma'am.
Thank you, ma'am.
Thank you.